Launch schedule for Falcon Heavy Mars cargo missions, 3 critical dates and projected costs by Q2 2025. Overview. SpaceX is poised to expand its innovative approach to space travel with the planned series of Falcon Heavy launches dedicated to Mars cargo missions. This initiative aligns with the broader goals of interplanetary exploration and the eventual human colonization of Mars. This report outlines 3 critical launch dates expected by Q2 2025 along with projected costs associated with these missions. Key launch dates. 1. First critical date, January 27, 2025. Mission, launch of Starlink Group 12-7 featuring approximately 21 satellites. Objective, this launch is part of SpaceX's ongoing effort to enhance global satellite internet coverage through its Starlink constellation. The satellites will be placed in low Earth orbit to provide broadband services to underserved regions. 2. Second critical date, February 27, 2025. Mission, SPHEREx and PUNCH missions. Objectives. SPHEREx spectrophotometer for the history of the universe epoch of reionization. ANISA's Explorer, this NASA mission aims to survey the entire sky, mapping the distribution of galaxies and understanding the universe's history. PUNCH polarimeter to unify the solar and heliospheric investigations, focused on solar research. PUNCH will study the Sun's atmosphere and its influence on space weather. 3. Third critical date, March 25, 2025. Mission, Crew 10 mission to the International Space Station ISS. Objective, this mission will transport 4 astronauts to the ISS, further solidifying SpaceX's role in NASA's Commercial Crew program and its commitment to maintaining human presence in low Earth orbit. Projected costs. The projected costs associated with the Falcon Heavy Mars cargo missions are substantial, with estimates suggesting that the total project expenses may exceed $10 billion. Factors contributing to this budget include development costs, significant investment in research and development for payloads and the Falcon Heavy launch vehicle itself. Operational costs, expenses related to launch operations. Ground support and post-launch recovery efforts. Infrastructure development, investment in launch facilities including upgrades to existing launch pads and landing zones. Common key points across sources. Launch vehicle, the Falcon Heavy, a derivative of the Falcon 9, is designed for heavy lift missions and has been instrumental in launching both commercial and government payloads. Reusability, SpaceX's focus on reusability has drastically reduced the cost of launching payloads into orbit. The Falcon 9's first stage boosters have achieved a high rate of successful recoveries, which significantly lowers the overall mission costs. Mission goals. The Mars cargo missions are part of a larger vision to support NASA's Artemis program and other exploratory initiatives focusing on delivering scientific instruments and infrastructure for future Mars missions. Differences between sources. Source 1 emphasizes launch statistics and performance metrics of the Falcon Heavy and Falcon 9 rockets, providing a quantitative assessment of their success rates. Source 2 focuses on the specifics of upcoming Starlink missions and the integration of new satellite technologies that enhance global internet coverage. Source 3 provides insights into the Vandenberg Space Force base launch infrastructure, highlighting the importance of SLC-4 for Falcon 9 launches and landings. Timeline of events. 2018, the inaugural Falcon Heavy mission took place, showcasing its significant payload capacity. 2023, preparations for Mars missions intensify alongside ongoing Starlink launches. January 2025, anticipated launch of Starlink Group 12-7. February 2025, liftoff of SPHEREx and PUNCH missions. March 25, 2025, scheduled Crew 10 mission to the ISS. As of January 2025, SpaceX has set an ambitious target of 180 launches in 2025, driven by increasing demand for satellite internet services and government contracts. This plan reinforces SpaceX's position as a leader in the aerospace industry. leveraging technological advancements and operational efficiencies to expand its mission capabilities. Conclusion. The upcoming Falcon Heavy Mars cargo missions represent a significant step in SpaceX's journey toward interplanetary exploration. With a carefully planned launch schedule and a focus on cost-effective operations, SpaceX is well positioned to contribute to humanity's understanding of Mars and the broader universe. As the launch dates approach, the aerospace community and the public alike eagerly await the next chapter in space exploration. Counterintuitive information in the content. 1. Projected costs exceeding expectations. The projected costs of the Falcon Heavy Mars cargo missions are expected to exceed $10 billion. This figure may seem high considering the advancements in rocket technology and the reusability of Falcon 9 and Falcon Heavy rockets. Many might assume that with the current efficiency and cost-saving measures the expenses would be much lower. But the reality of developing complex interplanetary missions adds significant financial burdens. 2. Ambitious launch cadence. SpaceX aims for a total of 180 launches in 2025, which might seem excessively ambitious given the historical launch rates. This figure contradicts the common perception that launch rates are limited by technical and logistical challenges, highlighting SpaceX's capacity to push the boundaries of aerospace operations. 3. Reusability versus cost. While the reusability of Falcon 9 rockets lowers launch costs significantly, the total mission costs for Mars cargo missions remain high due to extensive development and operational expenses. This juxtaposition may challenge the assumption that reusability alone leads to lower overall project costs. 4. High demand despite failures. SpaceX's ambitious launch schedule continues despite notable failures such as the upper stage anomaly during the Starlink Group 9-3 mission. This indicates a remarkable resilience and confidence in their systems, countering the expectation that failures would lead to a more cautious approach in future launches. 5. Technological advancements with Starlink. The fact that the new Starlink V2 mini satellites boast significantly enhanced capabilities, e.g. 4 times the data capacity of their predecessors while still being smaller and lighter than earlier models, contradicts the notion that increased performance typically requires larger, more cumbersome technology. 6. Growing military collaboration. The inclusion of Starshield satellites, which are classified and designed for military use in commercial launches, may seem counterintuitive. It suggests a blending of commercial and military space endeavors that challenges the traditional separation of these sectors. 7. High-performance launches with expendable components. The Falcon Heavy missions often result in the expending of the central core for high-performance launches, which may seem contradictory to the general trend of maximizing reusability. This reflects a strategic choice that prioritizes mission success over cost savings in certain scenarios. 8. Innovations in launch infrastructure. The rapid improvements in launch infrastructure, such as the quick turnaround times for landing and reusing boosters at Vandenberg Space Force Base, may challenge preconceptions about the time and resources needed for rocket refurbishment and preparation. 9. Unexpected recovery failures. The destruction of boosters during transport back to land due to rough seas despite successful landings illustrates an unexpected vulnerability in the recovery process. This counters the assumption that successful landings ensure complete mission success. 10. International collaborations. SpaceX's partnerships with various international entities for satellite launches reflect a shift in the space market. This trend may seem paradoxical given the competitive nature of the aerospace industry. Yet it indicates a growing acceptance of collaborative ventures for shared technological advancement and resource utilization. Each of these points illustrates a divergence from conventional wisdom about space missions, rocket technology, and aerospace economics, prompting deeper consideration of the evolving landscape of space exploration and utilization. Overlooked aspects of the Falcon Heavy Mars cargo missions. While the launch schedule for Falcon Heavy Mars cargo missions outlines several critical dates and projected costs, there are several significant details and implications that the general public may overlook, which could have a profound impact on the future of space exploration and technology. 1. Cost projections and budgeting challenges. One of the most striking details often overlooked is the projected cost of over $10 billion associated with the Falcon Heavy Mars cargo missions. This figure encompasses development operational costs and the infrastructure needed for the missions. The significant financial commitment raises critical questions regarding budgeting and resource allocation, especially considering the competing priorities within NASA and other governmental space agencies. The ability of SpaceX to manage these costs effectively while still meeting ambitious launch schedules could set a precedent for future commercial space endeavors. Significance: budget overruns and financial mismanagement could lead to delays or cancellations of missions affecting long-term goals such as human exploration of Mars. This cost must be contextualized within the broader scope of government funding for space exploration, which is often subject to political and public scrutiny. 2. Technological advancements and reusability. SpaceX is known for its focus on reusability, as highlighted by the successful recovery of boosters at multiple landing zones. The Falcon Heavy's design includes the use of 3 Falcon 9 first-stage boosters, which not only enhances payload capacity but also leverages SpaceX's technological advancements in booster recovery. This aspect not only contributes to cost savings but also represents a significant leap in sustainable space travel. Significance: the reusability of rockets is critical for reducing the cost of access to space and could revolutionize the aerospace industry. If successful, it will not only benefit SpaceX but also provide a model for other companies and nations to follow, fostering a new era of more frequent and affordable space missions. 3. Integration of Starlink technology. The integration of Starlink technology into the Falcon Heavy missions is another key detail that may be overlooked. As SpaceX continues to expand its satellite internet constellation, the inclusion of Starlink satellites in these missions is indicative of a dual-purpose strategy, enhancing global internet connectivity while also facilitating space operations. Significance: this dual-use approach could provide a competitive edge for SpaceX in securing contracts and partnerships with governmental and commercial entities. Moreover, successful deployment of Starlink in conjunction with Mars missions could lead to advancements in communication technologies that are vital for future long-duration missions beyond Earth. 4. Collaboration with NASA's Artemis program. The Falcon Heavy Mars cargo missions are positioned to support NASA's Artemis program, which aims to return humans to the Moon and ultimately prepare for Mars exploration. This relationship signifies a strategic partnership between commercial and governmental space initiatives. Significance: the success of these missions may directly influence NASA's future plans and public perception of commercial space partnerships. A successful collaboration could pave the way for further joint missions, enhancing the capabilities and reach of both NASA and SpaceX. 5. Environmental considerations. As the frequency of launches increases, so do the environmental implications. The Falcon Heavy missions will require careful consideration of the environmental impact associated with rocket launches, including emissions and potential hazards related to space debris. Significance: public and governmental concern regarding environmental impacts can lead to stricter regulations and oversight affecting launch schedules and operational practices. SpaceX will need to balance its ambitious goals with responsible practices to ensure compliance and maintain its public image. 6. Impact of regulatory frameworks. The operational environment for space launches is heavily influenced by regulatory frameworks which may not be fully considered in casual discussions about space missions. SpaceX operates within a complex web of international treaties, national regulations, and safety guidelines that govern space activities. Significance: the successful navigation of these regulations is essential for maintaining operational schedules. Any changes or challenges in regulatory environments could significantly impact the timeline and feasibility of planned missions. 7. Public engagement and perception. The public's perception of space missions is crucial for garnering support and funding. SpaceX's ability to effectively communicate the importance and benefits of its Mars cargo missions can influence public interest and investment in space exploration. Significance: engaging the public can lead to increased advocacy for space initiatives and more robust funding from governmental sources. The success of outreach efforts may determine the sustainability of public-private partnerships in space exploration. Conclusion: the Falcon Heavy Mars cargo missions represent a significant leap forward in space exploration, but they encompass much more than just launch dates and costs. The overlooked aspects, including budgetary implications, technological advancements, environmental considerations, and public engagement strategies, are crucial for understanding the broader impact of these missions. Addressing these factors will be vital for ensuring the success of SpaceX's ambitions and the future of interplanetary exploration. Key points for in-depth analysis and discussion on Falcon Heavy Mars cargo missions. 1. Launch schedule and critical dates. The Falcon Heavy Mars cargo missions are set against a backdrop of 3 critical launch dates leading up to Q2 2025. The first of these is the launch of Starlink Group 12-7 on January 27, 2025, which includes around 21 satellites aimed at expanding SpaceX's satellite internet constellation. Following that, the SPHEREx and PUNCH missions are scheduled for February 27, 2025, focusing on astrophysics and solar research respectively. Finally, the Crew 10 mission to the ISS is planned for March 25, 2025. Transporting 4 astronauts. These dates not only highlight SpaceX's ambitious launch schedule but also emphasize a strategic approach to prioritize both commercial and government payloads, illustrating how SpaceX integrates its missions to maximize efficiency and resources. 2. Projected costs and funding. The total projected cost of the Falcon Heavy Mars cargo missions is estimated to exceed $10 billion. This includes the development and operational costs associated with the Falcon Heavy rocket and its payloads. The financial implications of such a significant investment warrant an examination of funding sources, potential partnerships, and the economic impact on the aerospace sector. Additionally, analyzing how these costs compare to traditional aerospace missions can provide insights into the evolving landscape of space exploration, highlighting SpaceX's role in reducing costs through innovations like rocket reusability and rapid launch turnaround times. 3. Technological advancements and reusability. Central to SpaceX's operational model is the reusability of its rockets, specifically the Falcon 9 and Falcon Heavy. This technology has drastically reduced launch costs, a crucial factor in enabling frequent and economically viable space missions. The success of booster recovery, with a reported success rate of about 97% for Falcon 9 boosters, showcases SpaceX's commitment to innovation. Moreover, the Falcon Heavy's design, which integrates multiple Falcon 9 first-stage boosters, expands payload capacity and mission versatility. An in-depth discussion could center around the implications of rocket reusability on future space missions, including sustainability and environmental considerations, as well as how these advancements position SpaceX ahead of its competitors in the aerospace industry. 4. Mission goals and strategic importance. The Mars cargo missions are aligned with broader initiatives like NASA's Artemis program, which aims to return humans to the Moon and eventually send crewed missions to Mars. The goals of these missions include delivering scientific instruments and establishing infrastructure necessary for future Mars exploration. This strategic alignment underscores the importance of public-private partnerships in advancing space exploration goals. Analyzing the significance of these missions in the context of international space policy, scientific collaboration, and the geopolitical landscape can lead to discussions about the future of human space exploration and the role of commercial entities like SpaceX in that future. Conclusion. The Falcon Heavy Mars cargo missions represent a pivotal moment in the evolution of space exploration, characterized by ambitious launch schedules, significant financial commitments, groundbreaking technological advancements, and strategic alignments with major space initiatives. Each of these key points provides a rich foundation for further analysis and discussion on the future of space missions. The role of private companies in this domain and the broader implications for humanity's presence in space. Here are 3 famous historical cases that illustrate significant milestones in space exploration comparable to the anticipated Falcon Heavy Mars cargo missions. 1. Apollo 11, first manned moon landing 1969. On July 20, 1969, NASA's Apollo 11 mission successfully landed the first humans on the moon. Astronauts Neil Armstrong and Buzz Aldrin descended to the lunar surface in the lunar module while Michael Collins remained in lunar orbit aboard the command module. Armstrong's iconic words, "That's one small step for a man, one giant leap for mankind," marked a pivotal moment in human history and space exploration. The mission's success was the result of years of technological development and planning. And it demonstrated the feasibility of human space travel beyond low Earth orbit. Apollo 11 not only expanded our scientific understanding of the moon but also fueled global interest in space exploration, much like SpaceX's plans for Mars cargo missions aim to inspire future generations. 2. Mars Exploration Rover, Spirit and Opportunity 2004. In January 2004, NASA's twin rovers Spirit and Opportunity landed on Mars as part of the Mars Exploration Rover mission. These rovers were designed to explore the Martian surface and conduct scientific experiments to determine past environmental conditions and assess the potential for past life on Mars. Spirit operated until 2010, while Opportunity exceeded its planned 90-day mission by operating for nearly 15 years. Covering over 28 miles. The success of the Mars rovers advanced our understanding of the planet's geology and atmosphere and reignited interest in Mars exploration. The technological advancements developed for these missions laid the groundwork for future missions, including those envisioned by SpaceX for transporting cargo to Mars. 3. Voyager Program, Interstellar Exploration 1977. Launched in 1977, NASA's Voyager program consisted of 2 spacecraft, Voyager 1 and Voyager 2, designed for the exploration of the outer planets of our solar system. Voyager 1 famously provided detailed images and data of Jupiter and Saturn, while Voyager 2 went on to explore Uranus and Neptune. Both spacecraft continue to send data as they travel through interstellar space, making them the farthest human-made objects from Earth. The Voyager program was a monumental achievement in terms of engineering and scientific discovery, expanding our knowledge of the solar system and providing insights into the potential for life beyond Earth. This legacy of exploration and pioneering spirit resonates with SpaceX's ambitions to push the boundaries of space travel and establish a human presence on Mars. These 3 historical cases highlight critical advancements in space exploration, showcasing human ingenuity and the relentless pursuit of knowledge, much like the goals set forth in the upcoming Falcon Heavy Mars cargo missions. Future outlook: Falcon Heavy Mars cargo missions. As SpaceX gears up for its ambitious Falcon Heavy Mars cargo missions, the next few years are crucial for the company's trajectory in space exploration. With a projected timeline leading up to Q2 2025, several key factors will shape the future of these missions, including technological innovations, partnerships, and evolving market dynamics. This overview presents predictions based on current trends and planned activities. 1. Launch schedule and key dates. The Falcon Heavy is anticipated to play a pivotal role in delivering cargo to Mars, with critical launch dates identified as follows. January 27, 2025, the first significant mission is scheduled to launch the Starlink Group 12-7, focusing on expanding SpaceX's satellite internet capabilities. February 27, 2025, the SPHEREx and PUNCH missions are set to launch, targeting astrophysics and solar research respectively. March 25, 2025, SpaceX plans to launch the Crew 10 mission to the International Space Station ISS, transporting astronauts and cargo. As these dates approach, SpaceX will likely refine its launch cadence, aiming for a total of 180 launches in 2025. Demonstrating its commitment to scaling operations and meeting increasing demand for satellite and crewed missions. 2. Projected costs and budget management. The projected costs for the Mars cargo missions are estimated to exceed $10 billion. This figure encompasses the development and operational costs associated with the Falcon Heavy payloads and ongoing missions. To manage this financial commitment, SpaceX is expected to leverage its successful reusability model, reducing costs by recovering and reusing rocket stages. The continued success of Falcon 9's reusability will likely set a precedent for the Falcon Heavy as SpaceX seeks to maintain cost efficiency while expanding its mission capabilities. 3. Technological innovations and upgrades. As SpaceX prepares for Mars missions, several technological advancements are expected to be integrated into its rocket systems. Enhanced reusability. The Falcon Heavy's design, which combines 3 Falcon 9 boosters, will likely see enhancements that improve recovery and reusability rates, allowing for more frequent launches. Advanced propulsion systems. Developments in propulsion technology, including the use of Raptor engines in future missions, will enhance payload capacity and efficiency critical for Mars transport. In-orbit refueling technologies. SpaceX may advance its in-orbit refueling capabilities, enabling longer missions and greater payloads for Mars-bound missions essential for sustaining human presence and scientific research. 4. Strategic partnerships and collaborations. SpaceX's success in the Mars cargo missions will be bolstered through strategic partnerships. NASA collaborations. Continuing collaboration with NASA on Artemis and other lunar and Martian missions will provide SpaceX with essential funding and technical support, as well as valuable experience in crewed spaceflight. Commercial partnerships. Collaborations with private companies for payload delivery, such as satellite operators and scientific organizations, will diversify revenue streams and provide critical payloads for SpaceX's missions. 5. Market dynamics and competition. The commercial space launch market is evolving rapidly, with increasing competition from other aerospace companies. However, SpaceX's established track record and technological prowess position it favorably. Increased demand for launch services. The demand for satellite launches, particularly for communication and Earth observation, is expected to rise, providing SpaceX with a steady stream of revenue to fund its Mars ambitions. Emerging competitors. New players entering the market may push SpaceX to innovate further and reduce costs, ensuring it remains competitive in an increasingly crowded field. 6. Public engagement and support. Public interest in Mars exploration is at an all-time high. SpaceX's outreach efforts, including live launch broadcasts and educational programs, will likely continue to foster support for its missions. Building a community. Engaging with enthusiasts and stakeholders through social media and public events will cultivate a community around space exploration, which can enhance funding and support for future missions. Transparency and communication. Regular updates on mission progress. Technological developments and achievements will maintain public interest and trust in SpaceX's vision for Mars. Conclusion. Looking ahead to Q2 2025 and beyond, SpaceX's Falcon Heavy Mars cargo missions hold immense potential to redefine space exploration. With strategic planning, technological advancements, and a commitment to reusability, SpaceX is poised to not only achieve its ambitious goals but also to inspire future generations in the pursuit of Martian exploration. As the company navigates this complex landscape, its ability to adapt and innovate will be critical to its success in establishing a human presence on Mars.